Hey guys, Mr. Harper Smith here. So last week we were talking about z-tests in conjunction with means or averages. So average mineral content in water, average number of car accidents in a city in a year, average height for a person, average weight, okay? All dealing with averages. That's when we were using our z-tests. However, not everything in statistics deals with averages. For instance, sometimes it is dealing with proportions. For instance, what percentage of free throw shots do you make? Or what percentage of people in the school are male? What percentage of the people are over 5 feet tall? See, we're not talking about average anymore. We're not talking about the average height. We're talking about the percentage of people that are taller than a certain height. So there's a little bit of a difference. So here's the formula, you might want to write it down real quick, for doing a z-test on a proportion. What proportion of people prefer blue to green? What proportion of people have yellow as a favorite color? Okay, all of that, we would use a different type of statistic. Because we can't say, what's the average favorite color of a person? Well, if you take the average, you'd have to look at what everybody likes, mix those colors together, and you would probably get something close to some murky gray color, to be honest. Okay? So instead, we would talk about the proportions. That's where this formula comes in. So let's look at an example. If you need to pause it, write that down, go for it. Okay? So as an example, let's say that we have Joe. Joe is the coolest guy on the basketball team. He's just dribbling the ball. He's making a whole bunch of shots. And he claims he can make 80% of his shots. That's pretty good. Of his free throws at least. So we go to a game and we watch Joe during the game, and he shoots 50 times, and out of those 50 times he shoots, he makes 32 of the shots. Okay, well, if we do the numbers there, 32 divided by 50, his proportion, this is not p-value, this is the proportion of shots made. Sometimes we'll do p hat for this proportion of a sample proportion, is 0.64. Okay, that's 64%. Well, his claim was that he made 80%. 0.80. So let's see here, if we're looking at this, his claim, the null hypothesis in this case, would be the proportion is 0.8. That was his claim. We're thinking, nah, it's going to be less than that. So we're going to do our alternative hypothesis is P is less than 0.80. Okay. Notice we don't have anything greater than. We don't really care about greater than. You could say that his claim included anything greater than, because we're trying to prove that it's less. So we could say that it's greater than or equal to, but he technically just said it was equal to. So and we're just trying to prove that it's less. That's all that we're trying to do. Okay. So now we need to come over and figure out where we're plugging everything in. We've got our P naught, that's the null hypothesis. Null hypothesis is what he claimed. Our test is what we observed. It's our P hat. Okay. I go through and I just plug everything in. That gives me 0.64 minus 0.8 divided. I could put a 0 on the 0.80, but isn't 0.8 the same as 0.80? Come on. All right, we've got the square root of 0.8, 1 minus 0.8 over n. Now down here, the square root of p naught, 1 minus p naught, that is the standard deviation of a proportion. Okay, this right here, the square root of p naught, 1 minus p naught, is the standard deviation. You might want to remember that, you might not. I'm probably not going to ever put that on a test. You don't have to worry about that really from me. That's more of just for future reference. Then with our z-score, the formula we were using last week, we were always taking the square root of n. So if you're taking the square root of two things that are divided, you can just take the square root of the whole fraction and call it good. Okay, let's calculate this. Let me grab a calculator. We've got 0.64 minus 0.8, gives you a negative number. Then we've got so we're going to divide that by the square root of 0.8. This should be 50. Point 1 minus 0.8 divided by 50. And I got a z-score of negative 2.83. Now, if you look that z-score up in your p-value chart, we're looking it up, Silly math teacher should have had his p-chart out already, but he didn't. Silly math teacher. Hold on, I'm getting it. You should have the answer already. Fast forward to the scene in the video if you need to. See, z-test. I've got negative 2.83. All right, I get a p-value of 0.0023. Not a very big p-value. So up here, if our significance level had been 0.05, and it's a one-tailed test, is our p-value less than the significance level? It is. Since the p-value is less than the significance level, what do we conclude? Do we keep or do we reject the null hypothesis? In this case, we reject. Okay, because our p-value is less than alpha. I'll do a second problem. All right, problem number 2. So Sarah claims that at least 70% of students' cars have bald tires. Now, being bald doesn't mean that it's completely smooth. Bald tires, from a legal perspective, are usually like 2 to 30 seconds of an inch or less. Sometimes even 3/32 of an inch or less, depending on if you're in the red or if you're in the yellow, and what they're considering bald for warranty claim. Okay, so 2/32. So we go out and we've got our little gauges to check students' tires. I've actually got some here. If we were in the classroom, we would go out and do this activity today, but we're not. I'm sorry. So we go out, we check a whole bunch of students' tires, and we find out that 40 out of the 100 that we survey have bald tires. Okay, well, 40 of the 100. Let's go through and do a z-test and see if Sarah's right or if Sarah's wrong. Makes sense. So our p-value, not our p-value, p-hat, which is the proportion of our sample, well, 40 divided by 100 is 0.4. Sarah, her claim was that it was 0.7. Let's talk about our null and alternative hypothesis. The null hypothesis is that p is 0.7. At least, so greater than or equal to 0.7 in this case. So the alternative hypothesis, that's going to be less than 0.7. All right, and we're going to go with alpha of 10%, so 0.10. Well, let's do the test. Let's take these numbers and plug them in here. We've got p hat, our sample proportion, is 0.4 minus 0.7 divided by the square root of 0.7, 1 minus 0.7 divided by 100. Let's go through and figure out our z-score. We've got, let's see, negative 0.3 divided by the square root of 0.7 times 0.3 divided by 100. So I'm getting a z-score of negative 6.5. For rounding. When I go through and look at the p-value for that, it's like 0.00000000001. Super, super small. Now, was this going to be a one-tail test or a two-tail test? It's one-tail, because we're just going one direction. So it's a one-tail test. Our p-value is less than alpha. Thus, what do? Do we keep the null or do we reject the null? We reject. Okay, give it a try.